Good morning, everyone. Welcome to another Pure Maths workout, number 13. Seem to have got through quite a lot actually over these weekday sessions. I'm Stuart. If you don't know us, okay, I'm Stuart, a guy who does the videos on ExamSolutions.net, and it's great to see so many of the usual guys on the live chat that have come in, and also I noticed we've got a few new people out there, so welcome to you all. Michael from Air Maths Tuition should be on the live chat as usual. Michael, just gives us a thumbs up. Welcome to this morning's live stream. As I say, he'll be answering all your questions, comments, so do feel free to type in and ask anything. If you're new to this, you will be encouraged to answer questions and just have a go, okay? So you do need to get some paper, have a pen ready, okay, to jot down things. Will you need a calculator today? Yes, you most probably will, although I've designed the questions hopefully to fall out fairly easily for you. We're going to be looking at integration, and there's many aspects of integration, and this particular session is designed for working with integrating sine functions and cosine functions. Okay, now if you're an AS student, you wouldn't necessarily have done this, okay, it's not on your spec, but nonetheless I hope you'll get some value from it, because I'm going to be showing you some ideas, some formulas, and it's always good to be able to, as a mathematician, to also be able to see a formula, maybe not quite understand how we got it, but use it, okay? So it'd be good if you could take part as well by just looking at formulas that I'm going to put up, okay? So that gives you just a brief outline. Also ask you to jot down some of these formulas as we go along. I'll tell you which ones, because you're going to need them as we move further on. We're going to take this through the basics and of integrating sine and cosine functions, and then I'm going to get you to do an area under a graph and also a volumes of revolution question where we apply this particular stuff. Okay, so don't forget, you can look in the description anytime, and you should see some links to video tutorials, my website ExamSolutions.net, and good. Okay, don't forget to like this if you find it of value, or subscribe. Okay, so that's the intro. I've given you time, hopefully, guys, to get on board, and we'll get started. Okay, so right, let's just move over then to the screen here. Now, before we do integration of trig functions, just in case you're new, as I say, to this, some of you should be able to know what the differential of sine 5x is, okay? You have to use the chain rule here, but let's start, just throw this open for the moment and see if anybody out there can just jot down, enter in what the differential of sine 5x is, okay? Let's just put your answer in, okay? Differential of sine 5x. Go for it, okay? Do any of you know what the differential of sine 5x is? Erica coming in with 5 cos 5x. While I'm waiting for a few more of you guys, you might see this presented as y equals sine 5x, and you would then write dy dx equals whatever. And I can see that we're getting some of you taking part. That's good, and it is 5 cosine 5x, okay? So let's just put that answer up, okay? You'll see, whoops, it's gone off again. You'll see why I'm doing this, okay, in a moment. That's good. Differential of sine 5x is 5 cos 5x, okay? Now, if you were to divide both sides throughout by 5, okay, then what you would end up with is 1/5. Then I'll put it down, I'll show it, okay? It would be 1/5 of 5x. And integration then being the reverse of differentiation would mean that if we had to integrate the cosine of 5x, it would, I don't know whether it's a YouTube problem or not. Okay, just we'll pause for a while. Okay. Right. Just let me know, guys, when we pick this up again. Okay. How are we doing? Okay, we seem to have a problem. Not too sure what it is. Okay, it's come back. Okay. Is it coming back online for a lot of you guys? Yeah, you're back. Okay, we're coming back now. Sorry about this. I don't know what's going on. We don't seem to have had this problem on the earlier sessions. Okay, whether it's a problem, an external problem. Okay, I see you're all coming back now. That's good to have you back. Okay, let's just hope that we can keep this going. All right, if we have to quit, then I do apologize. We'll see what the problem is later. All right, I can see that. Okay, right, okay, let's carry on. Let us know if you go down, okay, again. So I'm going to just retrace. I don't know where you left me, but thanks for coming back. Hopefully you understood this formula, where I got it from, okay? So we're just going to move on then to differentiating cosine 4x. So what about that? Can you just put that answer in if you're out there and can do that? Okay, differential of cosine 4x if you know it. Okay, so differentiating cosine 4x. Okay, morning Nick. Okay, if you're just joining us. Trying to get people to differentiate cosine 4x at the moment. Okay, and I see one answer coming in from Erica. That's good. It is minus 4 sine 4x. So let's just move this thing on a little bit quicker now. Yep, it is minus 4 sine 4x. So again, doing something like we did here, if we divide both sides by negative 4, what we're going to get is minus a quarter of the differential of cos 4x with respect to x. It equals sine 4x. So if we were to reverse this, the integral then of sine 4x with respect to x must be minus a quarter cosine 4x plus a constant of integration c. And what this is generally leading to is a very similar result to what we had here, and that is if you integrate sine of ax, a being a constant, with respect to x, what you're going to get back is minus 1 over a cosine of ax plus a constant of integration. In this example above here, a was the 4. So if we had to integrate sine of, say, 3x with respect to x, it will be minus 1/3 cosine of 3x plus c. Okay? Right. So I'm sure some of you guys know this already. I'm going to hopefully work through a few examples, okay, just to double check, give you some further work to do. So here's the first integral. Just can you give me the answer to this one? And you'll notice I've put that 3 in the front just to vary it a little. So just see if you can give me back the answer to 3 cosine of 2x, okay, with respect to x. Okay, just see what we get. Hopefully it's not going to hang up again. I can see that we might have a problem. I'm getting signs here on the live stream saying that we possibly are overloading in anyway with her answer. -6 sine 2x. Okay, interesting. Let's just see how we get on with this. Anybody else? It looks like we might be hanging up, I don't know. Okay, some more answers coming in, differing from Erica's. Okay, we have one answer with 3/2 sine 2x and another one -3/2 sine 2x. Okay, good to see Kieran there with the constant of integration inserted. Okay, so good. Okay, well, let's just tell you what the answer was. Okay, it is 3/2 sine 2x plus a constant. So let's just check how we do that. Okay, there it is there. Okay, so we're looking at this formula here. You can see that the a is the 2 here, but we've got this constant in the front of the integral, and remember that when you've got a constant in front of the integral, you can either take the constant out the front. Okay, so that'd be 3 times the result of integrating cosine of 2x. So it's going to be 3 times 1/2 here, 1/2. Okay, 3 times 1/2 is going to give you 3/2, and then it's going to be sine of 2x. Okay, the a being that 2. And not forgetting that constant of integration, so well done. Okay, so hopefully that's been of some use to some of you out there. Okay, good. Got another question coming up. I just thought I'd give you this one. It's a little harder. It's going to be using this formula up here. Okay, think about what I just said over here with the constant in the front as well. Okay, so here it is, a little harder, but it's the integral of 5 sine of 3x/2 integrated with respect to x. So see what you can put down for that one. Just be good to see you participate in this. I'd encourage you to have a go. All right, just good to see how many of you out there can use your formulas that you're given. Okay, as I said earlier in the intro, it's always good to be able to be given a formula and be able to follow the form that it's trying to say. Okay, so we're looking for an answer to the integral of 5 sine of 3x/2 integrated with respect to x. Okay, so how are we doing? Remember, there's going to be a delay anyway before I see the answers from any of you guys. Okay, Erica coming in now again with an answer. Great to see you take part, Erica. That's good. I know you always do. And very encouraging. Okay, Kieran's coming in with -15/2. Cos 3x/2. Plus that constant of integration. Good to see the constant of integration going in as well. Okay. So it's just interesting. We're getting another varying answers. -2/3. That's 2/3 x, I think. Cos of 3x/2 plus c. So obviously this is proving to be a little bit of a challenge for quite a few of you out there. Okay. Good. Well, I can see some correct answers down there. What is the correct answer? Well, it's this, okay? It is, well, kind of this. Let's just check out what you would do. Like this one here that had a 3 there, a 5 here. So it's going to be 5 times the integral of sine 3x/2. So the a is going to be 3/2. Alright, so you got 5 times -1 divided by 3/2. So that's going to be -5 times 1/3/2. It's going to give you this result here. It doesn't look very nice, We'll tidy that up in a moment. But then you've got the cosine of ax. Remember, a was 3 over 2. So you've got cosine of 3x plus the constant of integration c. So what do we do here? I know many of you might say, oh, turn the fraction upside down and multiply. Yes, it's that, but technically we're multiplying top and bottom by 2. That will give us minus 10 on the top, and when you times 3 over 2 by 2, you just get 3. So when it's simplified, well done to all of you out there who got minus 10 over 3 cosine of 3x over 2 plus that constant of integration c. Okay, so great to see all of you taking part there. Well done. Okay, right, let's just move on. So I'm going to bring these formulas up again. Okay, there we are. All right, so you've got them there for this next exercise. Now, we've just seen how we can use the integral of cosine ax and sine ax, but I want to show you how we can handle integrals that involve cos squared ax and sine squared ax. So in order to do that, I'm just going to remind some of you guys out there of some formulas. If you're doing AS level, you should be familiar with this identity here. And if you're doing A level, you should be familiar with it. Cos squared of an angle, I've called it A, plus sine squared of an angle is identical to 1. Okay? Now, if you're doing AS, you won't necessarily have seen this, but if you're doing A level, you should be familiar with what we call the double angle identities. Cosine of twice an angle is identical to cos squared A minus sine squared A. And if we make cos squared A subject here, it's going to be the same as 1 minus sine squared A. So if I substitute 1 minus sine squared A in for cos squared A, I'm going to get 1 minus sine squared A minus another sine squared A, and that's going to give us this identity, 1 minus 2 sine squared A. Okay? And if we do much the same kind of thing and rearrange this identity up here for sine squared A, that's going to be 1 minus cos squared A. Okay? And if we were it in here and group together the cos squared A terms, you can check it later if you like, it will give you 2 cos squared A minus 1. And I've called these equations 1 and 2. So where am I taking this? Well, if we look at equation 1 and rearrange it for sine squared A, 2 sine squared A would be the same as 1 minus cos 2A, and if I divide by 2, I'm left with this result, that sine squared A is identical to a half of all of 1 minus cos 2A. Okay? Now I know I'm going fast here and you might want to spend some time just checking this out. What I'd encourage you to do though is at least write this down. You'll see why later on when we go to the next page. Okay? So do write down that this identity here. I can take identity 2 and rearrange it similarly for cos squared A, and if you do that you're going to get a very similar one. Cos squared A is identical to half of all of 1 plus cos 2A. Okay, so do write down these identities. I hadn't got room on the next screen to show these. Okay, so it's important that you do put those down if you're not aware of them. Okay. Right, so this is the end of the chat session, I should say, at this point. Okay, we're going to get straight into a question. Now, this is a kind of typical kind of question you're going to get on this: the integral of sine squared 3x with respect to x. So you've got to pick up on this identity, and for anybody who's new to this, okay, even if you're doing AS level, should be able to at least use this result and tell us what that integral would be that we would change this into. Okay, just let us know by saying done when you feel that you've got that far. Okay, just so that I can move on. Others of you might like to just work your way through and let us know what your answer is. Okay, or just say done when you're completely finished. Okay. Anyway, hopefully you've been able to convert this using this formula here into a better form. Okay, Pooh, good. Saying done. I'm assuming that, by the way, is just writing down what this integral is. Okay, at this stage, Gary's done. That's good. Okay, so I know you're out there participating in this. So what should you be doing? You should be changing this. Okay, we've got this. The A is the 3x. So when we double it, it's got to be 6x. So you should have this integral showing. Okay? Right, cool. So all you've got to do now is start to integrate this. Think about the formulas I've given you up here. Okay? And we'll go from there. Dare I ask you to type in your answer, okay, if you get it done? Okay, it'd be interesting. If you can go for it, just type in your answer. Don't forget that plus C, okay? If you ignore it, I'll ignore it, okay, at this stage. Just have a go at typing in your answer. Okay, this will be an interesting exercise because what I'd be looking for here is the most simplified answer you can give me. Okay, it's going to have fractions in it, but I'd like to think that you just give me a simplified answer with one fraction. Okay, let's go for it, see what you come up with. Often it's a bit of a challenge to simplify an answer when you finish it. Okay, as mathematicians, it's good if you can simplify answers. So how are we doing out there? Okay, have we got guys out there? Just say done if you've at least feel that you've answered the integral now. Okay, if you want to go further and type in your answer, that would be really cool. If you're just coming on watching this live stream, welcome. We're looking at integrating trigonometric functions. Okay. If you want to play this back anytime after the live preview, you can pause the video at any stage and try these questions. Okay, good. Gary says is done on this. Well done, Gary. Marcus, you've come in with an answer. It's good to see we're getting some answers coming through here. And interesting answers. Are they simplified answers? Let's see. I'll tell you what, I can see that Jasmine seems to have the right answer if I'm not mistaken, but Jasmine, it is not simplified quite as much as I would like. Okay. Anyway, let's move on. Okay, it's good to see that some of you guys are taking part. So let's see how we do this. Okay, if we integrate the 1, that's going to be an x. Okay, so integrating minus cosine 6x, okay, is going to be using this formula, but it's going to have a minus in the front. It's going to be minus 1 over 6 sine 6x. Plus a constant of integration. Let me show you, okay? That's what we're going to get. Now, when I glanced at what some of you guys had typed in, I can see that some of you have got this answer, okay? Half is 0.5. I think it was Jasmine. Yes, Jasmine's got that answer there. And I can see that if you multiplied this out, you're going to get the answer, I believe, that Paul has got there. Is it Paul? No, I can see that, Paul, you've got x over 2 for half x, but if we multiply this out further, surely it would be minus 1/12 sine 6x, okay? Plus that constant of integration. That is the answer, but it's not really simplified. I would pull out that 6, make it 1/12 there, okay? And that would mean you'd get 6x here minus sine 6x. I'll show you, okay? You should be familiar with that, okay? All I've got now is one fraction out the front rather than these two fractions. So I would say that that is simplified further this one. But well done, you've got that. That's the essential part at least. Okay, or half x minus the 12th sine 6x. Okay, but that is the simplified answer, I believe. All right, okay, so what I'd like to do now is give you another one to work out. Okay, now time is moving on. We've had a few hiccups earlier on with technical issues. Hopefully it's working okay now. We got this one here. Bear in mind we've got a number out the front and we've got this whole fraction here. It's just to step up the level, okay, but it's still following the same lines, okay. So you should be looking towards using this identity down here for your integral, okay. So have a go at that. Let us know when you have got that line, okay, so we can get you at least on the right track. Just say done when you feel that you've got the integral, you've simplified this further with an integral sign using this, okay. Just enter done and then we can check that you're on the right tracks. That part shouldn't take too long, all right. And we'll see where you're at. Okay, good to see some new people here today. I noticed Pooh's asking what am I going to be doing. These sessions tend to vary. Just keep checking on the link that you'll see there. You'll be able to see what the program is. It does vary a bit these days now because I rely on you guys out there telling us what you would like us to give, okay. So look at our program, and it's always 10 o'clock weekdays, except this Friday, by the way, okay, being a bank holiday. Okay, so Michael will be on tomorrow with a GCSE class, okay, so give me a break. I'll be on the live chat. Okay, I can see some of you guys saying you've done on that integral bit. You should have this, okay. Got to be careful here. The 3's gone out the front of the integral, and then using this formula, the a was 5/2, so if you double it, you're going to get 5x here, okay? So you should be on your way to integrating this by using this integral here, okay? Good, so just quickly let us know how you're getting on with that. Let us know when you're now done, and if you want to put your answer in, okay, in a simplified form, go for it, okay? I don't want to hang around too long here. I'm sure you guys can come back after this and just pause the video in various sections and review this. Go for an unsimplified answer even. Just get an answer up there. It will get you marks, okay, if it was an exam question. Okay, how are we doing? Okay, Kieran's come in with an answer there. It's having a look, Kieran, at what your answer is compared to mine. Okay. Doesn't seem to quite agree, Kieran. Okay, Marcus, you're coming in with a cleaned up version. Again, that one, Marcus, doesn't seem to yeah, it doesn't quite seem to agree with my version. We have another one from Paul. Let me have a look. Right, okay. I am going to give you the answer. Okay, you can check through. Okay, so if you were to integrate this, okay, I've taken the half out, so we've got 3 over 2. So you're left with integrating the 1 and the cosine 5x. So the integral of 1 is going to be x, and the integral of cos 5x from up here is going to be 1/5 sine 5x, okay, plus that constant of integration. Then what I've done, okay, I mean, if you expanded this, you're obviously going to get 3x over 2, 1.5x, 1.5x, okay, whatever. And if you were to multiply 3 over 2 with the 1/5, you're going to get 3/10 sine 5x, which would be 0.3, okay, sine 5x. I'm not really looking for that though, okay. If you're going to simplify it, I'd pull the 5 out the front, okay. Put it all over 5. That will be 5x here plus sine 5x all over 5. But that 5 can go out as a fifth, that 2 there, and we get 3/10. So if you simplify it, that's what you're going to get. 3/10 of 5x plus sine 5x plus that constant of integration. So do check that out. Come back later if you like and check that out. Okay? Right. Nice to see some answers up there though. As I say, Trey, yep, I can see what you've done there. Good. Okay. Right, let's move on. Sorry guys, it's taking a bit longer than I thought. I'm going to take this further. Good if you can stick with us, okay? Let's just take this one, applications now. You could be asked to do a question like this. Find the shaded area of y equals 3 sine 2x. Now we're definitely moving up into the A-level sections now, where we're dealing with radians. And if you're doing AS level, radians not necessarily covered. So you might need to think about this, okay? However, when you're finding under a curve, you need to integrate y, that's this equation, with respect to x between your limits. That's this limit here, which is clearly the origin, 0. But what is this value here? Where does the curve cross the x-axis, I should say? Okay? It's not at 1.5 as you may suspect when you look at this, by the way, okay? What is this value? What's the exact value there? Anybody? Okay? Let us know before we carry on. You're going to need to know that value where it crosses the x-axis. Okay? So where does it cross the x-axis? Look, you're going to need to work out an equation there. Anybody? So you're looking to solve the equation when y equals 0. Okay, when y equals 0. That's going to mean that 3 sine 2x is going to equal 0. You've got to solve it for x. Okay, anybody? Okay, no takers. Quarter pi, good. Mr. Bowles coming in there. Quarter pi, pi over 4. That's the equivalent of 45 degrees. We're working in radians here. We've got pi over 2. Okay, we have Mr. Bowles back again. Half is. Okay, sorry, my mistake. Gary, pi over 4. It is actually pi over 2. Okay, let's show you. Right? Crosses the x-axis when y equals 0. So we put 3 sine 2x equals to 0. That means that sine 2x would equal 0 because 3 can't be equal to 0. Okay, so sine 2x equals 0. And that means if you take the inverse sine of 0, you're going to get 2x equals 0. Or pi. Pi is the equivalent to 180 degrees. Okay? Divide by 2 and you have got x equals 0 or pi over 2. Okay, the equivalent of 90 degrees. Right, okay, it's pi over 2 there, that point there. So, what's that integral going to be? Well, you should know that the area, as I say, is the integral of y with respect to x between these limits, 0 to pi upon 2. Now, if you have never done radians before, you can integrate this, okay? And instead, when you get down to the end, we've got to substitute these values in. You could put 90 degrees in your calculator as long as you're in degrees mode, and you will get an answer, okay? Anyway, I'm going to let you loose on that one. See what you can do with it, okay? 3 sine 2x. All I'm doing now is applying what we've seen before, okay, and using it in a definite integral, all right? Okay, so it could take you a little time here. I'm looking for the answer for that area. Okay, Jasmine has said it's 3 over 2 square units. Great to see the square units, by the way, Jasmine, okay? If you've been here before, I think you have, you'll know that when it comes to area, I always kind of like to put those units in. Okay, not that in an exam they're going to knock off marks, but I do believe that you should be writing square units there. Okay, so we're looking for that area. Jasmine came in with, I think it was 3 over 2, but deleted her answer. That could be a sign that was unhappy with it. Gary now coming in with 3 square units. Okay, 3 square units. Anybody else? Right. Okay, I'll take one more answer. Okay, let's see what comes in. We're going way over my time schedule here. We're on 40 minutes. Thank you very much, guys, if you've stuck with this. If any of you decide to leave, you might want to come back later. Mr. Bowles, 3 units squared. Good, well done. Okay, that's it. It is 3 square units. Let's show you how it's done. Okay. Hopefully you're able to integrate 3 sine 2x from what we've been talking about before. It's minus 3 over 2 cos 2x, okay? Then you just need to substitute your values in, okay? And if you substitute those limits in, you're going to get this result here, okay? 2 lots of pi upon 2. Now remember, I did say to you, you could convert that if you're in degrees mode to 90 degrees, okay? With those 2's cancelling out, okay, you're left with pi. So that's going to give you 180 degrees. So you could do the cosine 180 degrees minus the cosine of 0 degrees. It will give you the same answer. But if you're in radians mode, it's cosine of pi minus the cosine of 0. All right? Put those values in, evaluate that lot out. You should have this. Okay? Cosine of pi is -1 minus the cosine of 0, which is -1. Is 1, I should say, but you got that negative there. Simplify that, and you're going to get 3. 3 units squared, 3 square units. Well done to all of you out there who had a go on that one. Okay, last question now. Okay, it's going to be on volumes of revolution. Why are we going to be looking at volumes of revolution? Well, you'll see why. Hopefully you jotted down all that stuff I talked to you about, those formulas on integrating sine squared, okay? Because this is a question on integrating sine squared functions. We've got to find the volume of revolution of that shaded area that we just were looking at, okay, about the x-axis. Give your answer in the form k pi squared. And if any of you guys out there know about this stuff, then do carry on working ahead, okay? I've given you that value, that limit there. It was pi upon 2 radians, okay? The equivalent of 90 degrees if you're working in degrees mode. Okay. If you haven't done volumes of revolution, just a quick update. Okay. A volume of revolution is when we take an area like this one that I've shaded and spin it about the x-axis through 360 degrees, or 2 pi radians as questions say. It will generate a solid of revolution. Now, you can't quite see it in this diagram, but if you were to rotate it slightly, hopefully you get a vision of what it would look like. Okay, something like that if you were to spin this area about the x-axis. And how do you find volumes of revolution about the x-axis? Well, this is the formula. The volume of revolution, I've called V, is given by pi times the integral of y squared. So in this case, it will be this function here, squared, with respect to x, going between the limits a and b. And those limits will be 0 here and pi upon 2. So you should already be thinking about this integral here. Okay, there we go. So hopefully you should be able to do this now. Okay, and see if how many of you can come up with this. We might have had a slight problem there on the live stream. I just looked across to my other monitor and I think it is pausing. Okay, so can you just tell me if you're out there and you are still connected to this? Just say something like you're okay, connected or whatever, just so that I know. I got a feeling this might have hung up. Okay. Just let us know if it's hung up on you, guys. Hopefully not, but we have been having problems today. I can see Michael saying all good, Stuart, so that's good. Okay. So we're looking for that value of k, by the way. Okay, that's good. Just to make it simpler to type in, if you can give me the answer of what k is, that might be good. Okay. Just it's going to be something pi squared. I'm looking for that exact value of k, if you're still with me. Okay. Yeah. Right. Okay. So we're going to have to try and get this problem sorted out. I don't know whether it's a YouTube problem or not. It could be just literally the at my end. Okay, I see that I've got an excessive use of CPU here, which could be the problem. Looks like I might need an upgrade. How are we doing with trying to find out that value of k? The answer will be something pi squared if you're doing it correctly. Okay, C will be the first in with this. I will be showing you the answer. Okay, right, we've got K coming with Jasmine. K is 9 over 2. We'll take another one, okay, just in case Jasmine's got it wrong. We've got Mr. Bowles with 9 over 4. Two differing answers. One more. Let's just see, unless it's different. Good, Colin's come in with 9 over 4. And guess what? Yep, it's 9 over 4. Well done. Well done if you've got 9 over 4. Let's just quickly take you through this and we'll wind this live stream up. Okay, if you simplify the integral, okay, you'll see the 3 squared I've written as 9 and I've brought it out the front. And when we look at the identity, remember the identity for integrating sine squared a was 1 minus cos 2a. Okay, if you jot that down from the earlier page. So all I've done is double that 2x, 1 minus cos 4x, and the half that we would have had, I've pulled it out the front. Okay, so it means that this integral should be fairly straightforward now. When you integrate that, okay, you're going to get an x here when you integrate the 1, and as we've been working through, the integral of minus cos 4x is minus a quarter sine 4x, okay? And we've got our limit here. If you're working in degrees, okay, then the pi over 2 is going to be the equivalent of 90 degrees that you'll need to substitute in here. It is easier though to work in radians. If you substitute those values in, you can see that we can do a bit of cancelling here, and you're left with the sine of 2 pi there. Okay, when you substitute 0 through, you're going to get 0. Okay, so it's just a question of working this out. If you work it out, keep it in exact form, just leave those pi's in. Okay, the sine of 2 pi is 0, so you're just left with pi upon 2 here. So 9 pi over 2 times pi upon 2 gives you 9 pi squared over 4 units cubed. Okay, that was the question in ways. It was to give that volume, okay, in that form. I just thought I'd ask you what k was, okay, and k would be 9 over 4. So well done anyway to everyone out there who's taken part in this. Okay, so as I say, do come back, and I'll come back on screen as well. Do come back and check this out in your own time if you want to run through that. And it just leaves me to say thank you very much for coming on board and taking part, and hope you got something from that. Don't forget to give us some likes if you did get some value. Okay, took a bit longer, as I say, this session than normal, and it gives you as well, hopefully, if you haven't done it gives you some insight into applications of integration. If you're doing AS, what we tend to do at A level. Okay, so always good for you guys to see that. Okay, and hopefully it might give you some point and some to this, and get you motivated to do A-level maths. It's a great subject. Okay, so stick at it in these difficult times. Okay, so have a good day. Michael's on tomorrow with GCSE maths, all being well, no technical problems, and we'll see you. Okay, bye for now.